Assalamualaikum warahmatullahi wabarakatuh. Thanks to the moderator. Good afternoon, ladies and gentlemen. My name is Herlina from University of Mataram. Today, I'd like to present about mechanical and morphology properties of Hibiscus tiliaceus powder, polyester composite, the effect of alkali treatment and volume fraction. Ladies and gentlemen, we all know that recently it is a common application to use particle material as a filler to improve engineering properties and lower the cost of finished product. The potential for hibiscus that is abundant and renewable still need to be developed for a wider application. The use hibiscus powder as a reinforcing material in polymer composite has not been studied. In this study, we should know the effect of alkali treatment and volume fraction on the mechanical properties of hibiscus powder composite. Therefore, mechanical properties of the hibiscus powder filling composite are investigated by tensile test and SEM methods. It is aimed to understand the effect of the alkali treatment and volume fraction on the mechanical properties and morphology of the polyester composite. Alkali treatment process of hibiscus powder begins with the powder immersed in 5% with a potassium hydroxide solution with the different immersion time, namely 2 hours, 4 hours, 6 hours, and 8 hours. And then the powder filtered using a cloth to remove the alkali liquid from powder, and then they rinse with clean water 5 times and dry using an oven at a temperature of 105 Celsius, and then we did the powder treated. Ladies and gentlemen, as you can see in chart, we know that the tensile strength of the hibiscus fiber increased by up to 700% after the fiber treated potassium hydroxide. The tensile strength of the hibiscus fiber increased due to the reduced hemicellulose of the fiber and the increase of the cellulose content of the fiber and rugged surface of fiber after treated potassium hydroxide. As you can see in chart, we have found that the composite with a powder of 5% and 10% volume fraction have the tensile strength, elongation, and Young's modulus value tended to increase after the powder treated for 2 hours, 4 hours, and 6 hours. From this chart, we know that after being immersion in potassium hydroxide, the interfacial bond between powder polyester becomes stronger and ultimately resulted in a higher tensile strength of the composite, which was indicated by change in the powder surface becoming rough. The tensile strength, elongation, and modulus of elasticity of the composite decreased after the powder was soaked for 8 hours, which was related to the powder being damaged and a pull out of pore, so that it was less able to continue the polyester stress. As a result, tensile strength was reduced. Ladies and gentlemen, as you can see in chat, we know that the powder treated for 2 hours, 4 hours, and 6 hours give an increase in the flexural strength of the composite by 6%. And then at a constant volume fraction of hibiscus 5%, the flexural strength of the composite was obtained at 84 megapascal and 82 megapascal and 80 megapascal respectively. The increase in flexural strength directly affects the increase in the flexural modulus value. This result implies that the surface modification of hibiscus powder with potassium hydroxide has an effect on increasing the interface bond between powder and resin so that the flexural strength is high. At 5% and 10% volume fraction, the flexural strength of the composite decreased after the powder was treated for 8 hours, which was associated with the powder breakdown and reduce composite stiffness. At the 20% the powder, the flexural strength of the composite decreased drastically for each specimen studied. This was mainly because the large number of powder causes less powder movement during pressing. As a result, the polyester resin could not completely wet the powder. Ladies and gentlemen, as you can see in figure A, C, and D, we know that the interface bond between the powder and matrix is dense. The hibiscus pull out and fracture occur along with the matrix or resin in the composite, resulting in low mechanical strength. Furthermore, figure B shows a tighter interfacial bond between hibiscus powder and resin in the composite than other composite. This supports the reason why the strength of the 10% powder treated for 6 hours composite is the highest compared to other composite. Ladies and gentlemen, in concluding discussion, we can note that at the 5% to 10% powder volume fraction, the tensile strength and flexural strength tended to increase by about 34.27% and 6% after the powder treated in 5% for 2 hours to 6 hours, then decreased after the powder treated for 8 hours. The highest tensile strength and the flexural strength were obtained from the composite 10% for 6 hours of 58.73 megapascal and 93 megapascal respectively. The increase in strength was associated with a stronger and denser interface between resin and powder because the surface roughness of powder increased after being treated for 2 hours to 6 hours at 20% powder volume fraction. The mechanical properties of the composite decrease because of the interface bond between powder polyester was reduced because of the powder was not evenly weighted by the resin and powder pull out. For composite, after powder was soaked for X hours in potassium, the powder become damaged and easily broken, causing the composite strength to also be low. This study implied that the immersion time of a powder and the volume percent of the powder affected the mechanical strength of the composite. Okay, ladies and gentlemen, it's been a great discussion with you all. We don't feel like we are the one who presents something, but we all did. Thank you very much for your great attention and active participation throughout this presentation. I will return the time to the moderator.